Hello, I'm Jay Corner, student number 163-18711, finalising my 4th year in computing in NCI while specialising in the software development stream. For my final year project, I've decided to develop an Android gaming application called Roadster Run. Roadster Run is an endless runner car combat game with a customisable player car and augmented reality functionality. This game is aimed at all types of players with Android phones and those who like fast-paced action gameplay. There are 3 core features to the application that can be broken down into game, store and Aor Card Display. The game features a player car driving down a procedurally generated road level while engaging with enemy vehicles in gun combat. The store feature is a way for the player to customize their vehicle that displays in all features of the application. Currently, the user is able to swap out the car body and paint color of their customizable vehicle. The Aor Card Display feature allows the user to display their customized car into the real world. This also allows them to capture images of the car to be stored on the user's device. My main inspirations for the application was the procedural generation of the game Subway Surfers and many other endless runners, the car mechanics used in the game Traffic Racer, and the visual elements and arts are heavily inspired by the Mad Max series of films. The game feature of the application is an endless runner style game. This format is very common in mobile games, where a user will be locked to 3 lanes to run away from a threat and dodge procedurally generated obstacles. In Roadster Run, the player-controlled car is not locked to a single lane and has full freedom of movement. The player is asked to face the threat head-on and to engage in combat with the enemy vehicles. The player also controls the car using motion controls of rotating the device to turn left or right. The store feature allows the user to customize their player car in many combinations. This personalizes the experience for each player. The Aor Card Display incentivizes the customization features and places Roadster Run logo branding on top of the captured images. This should generate more users and exposure to the application if these images are shared on social media. Roadster Run was developed using the Unity engine. This is a familiar framework for me from making 2D games in the past, but this has been my first dive into 3D game development. Unity comes with a host of tools that helps its developers create games and interactive experiences. C# is Unity's and my language of choice. I use this language to create game systems, save systems, Aor functionality, UI handling, scene management, sound triggers, and many more functions that are involved in Roadster Run. Android is the target platform for the Roadster Run application. This involves designing a game around touchscreen controls. As augmented reality is only available to Android versions 8 and over, I had to install all the necessary SDKs and Gradle build files to work alongside Unity's project builder. Aor Foundation was a plugin downloaded to my Unity project for Roadster Run. This plugin allowed me to create a framework for basic augmented reality functionality and includes the Google-made Aor Core API, which allowed me to access more advanced features such as light estimation. I personally created all the art assets that are included in the application. As the game is a 3D based game, I had to create all the car models and road tiles with the 3D modeling software Blender. As Roadster Run is a mobile based game and I didn't want lower end devices to have performance issues, I kept these models with a relatively low poly count, coming in under 1,000 faces per object. Photoshop was used to create various 2D elements within the project. This includes the logo, elements for the particle systems, and all the graphical user interface elements. When creating systems or functions for the game, I implemented a unit testing strategy. I tested functions as they were created to see if they performed properly and did not cause any bugs or errors with the other systems in the game. In the game feature, I created a function that allowed me to control the player car using the buttons on a keyboard. This prevented me from needing to build the application to my mobile device every time I needed to test a function that was in development. Performance testing was a big part of how I approached the application. I would build a small content update to my own personal mobile phone for testing and upload big content updates to Google Play for the internal testers to try. This step was important for the augmented reality functionality, as I needed the device camera to test the features. During performance testing, I would check to see if the frame rate was consistent in all features, if all the save data was working for the customizable car in each instance, and seeing if the images taken with the Aor car feature were saving to the user's device. I would ask each of the internal testers how their experience was with each content update, and for feedback regarding how the systems felt to use and if the user interface was easy to navigate. This feedback would heavily influence where I spent my time optimizing the application using the Unity profiler. So here we are in the Unity editor, where we can see the CPU usage and different color codes for each of the objects that can be intensive on the system. This average runs at around 200 frames a second on my computer, but as a mobile phone will not have as good hardware within it, it is good to have very optimized on PC, so then we can see that it runs smoother on mobile phones. Its lowest FPS is 60 frames a second, which is very good, which carries over to the mobile version. So here I'll press play and we can see how this works. It basically takes into account all the functions that are running, all the objects that are being rendered. We can see here the frames per second. It goes up to 100 frames per second sometimes, and I could even pause it and do a deep dive. See there's particle systems that are playing the drawing of the objects, some camera render. So these are the things that are potentially causing these spikes, but as I've said, the worst it's getting to is 60 frames per second, which is very good for it's well optimized for a game. So here we are in the main menu of Roadster Run. All the assets were created by me in Photoshop or Blender, and we can see the customizable car featured on the main menu. Here we're going to the store feature to change the save file for the car to set a new customizable look. So we're going to set the body to the Ford and the color to purple, and now we can rotate the car using a script to just view the object. So next we're going to head into the game feature, where we can see all the features created. So here we are driving down a procedurally generated road that is generating enemy cars that are called the X-Blow. So you can see there we can shoot the car and it generates a action flip and a particle system. There I've pressed the slow motion button in the bottom left. Everything is moving slowly and making it easy for the player to dodge in and out of cars. As I was saying, you can tilt the device to move left and right, and when you crash into a car, it provokes a game over state. So now we're going to test out the Aor car feature of the game, which allows the user to display their customized car in an augmented reality environment. So here we are trying to place a car on my table using that icon that showed up that notifies the user of flat surfaces where they can place the car. So there we've changed to the medium setting, which is more the same size of a remote control car, or now we're back to small as it didn't fit on the table, to more of a toy size car. There we've pressed the capture button and taken an image, and there I've pressed the reset button to reset the function and be able to place the car in a different spot. So now I'm going to place it on the floor, and let's have a look at that medium setting with actual space. So here we've come back to the store to change the save features once again. So let's change the car body back to DeLorean and the color to red, and as you can see it's changed in the main menu as well. Here in the game mode it is also changed. Everything's working perfectly. We can provoke going back to the menu by pressing the pause button in the top left. And now we're going to see the Aor car function working with our new player model. And there we go, the red DeLorean car. So here we are in my phone, and we're going to click on gallery and find the folder Roadster Run. And here we can see all the images I've taken using the Aor car feature. So here we are in the Unity editor of the game Roadster Run. As you can see, we have the scene view here with a few objects set up. This scene is the main menu, and we can see at the bottom here we have 4 different scenes that the game goes through. The main menu, which then can access the game using the play button. It can access the store using the store button, and the Aor display using the Aor Card button. Quit just runs a function that allows you to exit the game, and all the buttons run these types of scripts where it would scene manager.load and then the type of scene. So here we are within the game scene in Unity, and I'd like to talk about the player object. There's no road tiles yet in the scene, as they are generated when the player presses play on the scene. So I'd like to talk about the player object, which we have a card movement script attached to, which I wrote myself, a rigid body component which gives the car weight, slow time, which is that ability mentioned in the bottom left button, and then audio sources and box colliders so they can handle collisions with other cars. So within the object here in the hierarchy, we have the player base, which holds onto the car bodies. Here the different types of car bodies that are able to be equipped based off the save system, which I'll get into later when I talk about the store feature. Here in the wheels we have the wheel model, and on top of that we have wheel colliders. Wheel colliders are basically a kind of box collider which allows you to generate force of torque and have it physically touch an object and rotate. So the car can be based in a realistic physics system. So we have 4 of these, 1 for each wheel, and we have a particle system for the explosions on the death animation. So here we pass each of the colliders into the car movement script. As you can see here, front left vertical input is an editable number that can help me change different speeds which the player can rotate. A lot of these objects which I can change numbers to change how the car will handle in incremental ways, so I can find the perfect balance for the player. So here we are in Visual Studio Code, where I would like to talk to you about a few of the functions that let our car move. So here in Fixed Update, which gets called every set frame of the game, it's an accelerate function, which means the car is always moving forward. So if we could go find the accelerate function here in accelerate, first thing I'm trying to do is find the current speed, as this is important to let me know if I want the player car to be accelerating or not, as I don't want the car to infinitely get faster. Here we're taking the mentioned wheel colliders and applying torque to the 2 back wheels. So here we have, if it's under the max speed, we do the accelerate function, which is applying the torque, which is making the car move. And if it's over the max speed, to handle make them not go too fast, we don't apply any motor force. Important part of this is applying this rotation to the visuals, which is done through this function, apply local position to visuals. This is what takes the child object off the collider. We see we're passing in each of the wheel colliders, and it sets the local position of that wheel collider so they both rotate together, which makes it look great. So here we have also changing pitches of the car's engine noise, which is based off the current speed. So depending on the speed, it changes pitch just like a normal engine would. Another function I'd love to talk about is the tilt, the move tilt. So here we have in float temp input dot acceleration x is what's taking the input from the player's rotation of the phone left and right. So here we have we're applying a force if it is under over 0.001, it moves left, and if it's under minus 0.001, moves right. The 0.002 difference between the two is a nice medium point between this and this, so the player can drive forward without any having to hold their phone too stable, as it was just difficult to play and drive straight. So I give them that kind of buffer. Here we have rigid body constraints, which allows me to fine-tune how the car is being rotated. So I don't want the car to be swerving or doing anything. I want it to be a lane system where it's moving in and out of lanes nice and slickly. It makes it easier to design systems with and to control the player's experience, rather than have them go fly off the map or do something that's not involved in the game. As I mentioned, generated road tiles, I would like to talk about the level controller object. Here we have an array list which takes in prefabs preset here, which contain a road piece and an enemy position. So here in the level controller we have the array list of size 5. We pass in each of those road objects and we give it a probability value. The probability value is the likely chance of it being spawned within the level. So here I'd like to open the script and go through a few of the key functions which make this work. As we can see here as well, actually we have a draw distance of 35. That means 35 objects of road will always be spawned in the scene. So here, if we go to the code, we can see at the start the spawning of the level pieces and the dequeuing or destroying of the level pieces, and the enqueuing of it is based off the current camera's position. So here we need to take the current camera's position at the start and set the last to current. We build a probability list, which is what allows us to use probability to spawn different pieces. So at the very start, the draw distance I mentioned, we add 35 new level pieces, which uses spawn new level piece. So here we have spawn new level piece, which takes a random number between 0 and the number of objects which are in the list. And now we instantiate a level piece based off the number that's selected. So here, the piece index, and we place that in the right position, which is based off the current cam position and the amount of player tiles that have already been instantiated and deleted. So this has been set with the normal rotation, which I preset by making it, and the active pieces are it's enqueued to a list called stack list called active pieces. So basically it gets added on the top of the stack, and the level piece at the very bottom gets removed. So it gets moved constantly forward by 35 pieces. So here we can see in destroy level piece, which gets called when we spawn a new level piece based off the update function, which is based off the current cam position, or if it doesn't equal the last cam position in the incremental way of how many pieces have been spawned. It destroys level piece and does the spawn new level piece. Destroying a level piece just destroys the last objects in, or the first object in the stack, and then destroys that level piece within the world. So this means we constantly have only 35 road pieces moving along with the player, and this is great for memory and performance on the device. So here we are in the store scene, where I'd like to talk about the store handler, which sets the car to its specific color or specific body. This also comes along with the save feature and load feature. It's what actually sets the data correctly to be called in other scenes. So here we have the store handler, where in the store handler we have store manager, which just handles UI logic. We have cosmetic colors, which is to do with the color buttons, and we have cosmetic car bodies, which is to do with the car body buttons. We can see all the buttons at the moment because we haven't ran the thing, and the store manager hasn't set the logic to be like only these should be shown or that should be shown. So I'd like to talk about cosmetic colors. So here we can open the script here, and so at the start we initiate a list of color types. So color types is a class made by me, which stores a RGB color value and a name. So here we are building the list. So these are all the different lists. the different colors that can be applied to the player, and that's set in that list of color types that's just created at the start. And when a button is pressed for a particular color, it passes in a string of the name of the color, which is why there's a name in the class. So that does change color. So here we have for each color and color types, we search for the name that's passed in, which is the C variable. Here we look for the one with the name, and then when we find that one, we set the player color dot color to the color RGB color value, which is stored in that position in that list. The player color dot color is actually a material that is consistently set on all the different car models. So they have different materials set to like their lights or their bumpers or other objects, but they all, on the skin of the car, it has the same material variable which can be edited, and that's why when you change one car body red, all the other car bodies will become red once you switch it in between. So I'd also like to talk about the save system script. So what this basically does is it finds the store handler object which in the store scene, and then it gets the various components that are set in each of these like setting scripts. So here we're finding the cosmetic color, which the car color was set to when we press that button, and then the cosmetic body, which is a string that the car body will be set to when we set a new one. In the car body, it also initiates this data builder function. The data builder function then also goes to the save data function. The save data function uses the binary formatter and sets a path within the application and sets the document called cosmetic.data. Then a file stream is open where the path is set in and its function, which is to create a file, and then we format the data cost. The data cost is a class of all the data that could be possibly passed through for the cosmetic data. So here we're passing in that data that was set in data builder, and we are putting it in the stream which was set there, the create, and then we close the stream after to prevent any issues of stuff being overwritten on other save features or load features, and then we just do a debug script. So I'd also like to show you the Aor Scene. So this is kind of hard to visualize as we don't have any camera, but here is the UI basically for that can be set within it. So the Aor works through a plugin called Aor Foundation, which gives us this object Aor Session Origin. This is what helps us to set up the camera within Unity and gives us an origin to play stuff. So this we have our UI camera created by me, which is an overlay that just generates the UI scripts, the UI objects, and then we have the Aor camera. This is one of the main scripts that is used within the Aor functions. So the place car, which will place a car in a given position given by the placement indicator script, which is also written by me. So this just places it in a stored location that's based off like bump maps that set points in your camera. So here we set the placement to true. We have the remove car function, which will remove the car. We have change size functions. I'd also like to talk about the take screenshot script, which uses it just does UI setting where it sets the logo to true and hides everything for a second and then captures the image. And here is a similar type of system to the cosmetic data, where we're taking the file name, the location, the photo location, the screenshot location. This goes more deep as it's actually trying to save it into your gallery file for Android devices. So using system.io directory once again. And we're using Android Java classes to actually access the Android files within your phone. And then we send a broadcast with the object intent, which is set with the image with the correct branding logo. I would also like to talk very briefly about the load system that's used for loading the cars in each of the scenes. So each of the scenes would have a car similar to this one, where within the car they have a player base, and attached to that is a car body where we'll set these to true or false. At the start of every scene, it loads the data from the save system. So it loads the data from here, load data, where different scripts such as Cosmetic Colors at the very start can access this load data, which it's taken from cosmetic data. So this happens to many different objects, car objects that's used in the scene, the game, the main menu, and the Aor. So at the start of every scene, it pulls the data, sets the data, and then we're fine from there. The store feature is the only one that can overwrite the data by pressing the many various buttons on offer. I found the Aor car functionality to be quite a step up in my skill in Android development. Using the device's camera was something new to me, and being able to create my own UI and functionality using this camera was quite difficult. I particularly found the saving the images to the device very difficult and challenging task, but I'm happy that the feature is fully functioning for the final upload. Using augmented reality features to market a game isn't something I've seen before. I feel bringing in the customizable element of the player car will bring more personalized experience with the application. This was my first introduction into augmented reality features, especially with Android and Unity, and this is my first experience with modular car customization, and then combining the two together I found quite innovative and something I haven't really seen before. Also, the binary formatting for the save feature is very safe for preventing people from stealing the data saved or editing the data. I wouldn't say much has changed in the project since the requirement specification. I would say a lot of the things that I promised I didn't know how to do when I wrote them down, but did eventually figure out a system where it could be achieved. If I take the customizable cars for example, I had no clue how I'd be able to change car bodies and car colors, but I came up with this system that allows me to call different colors from an array list, or even different stored 3D objects in an array list, and set them true or false on the player car for multiple cars in the game. And for stuff that was added, there was a few things that were added, like procedural animations on like death of cars, and the time slow ability I don't think was mentioned in the requirement specification. I think I've overscoped during the requirement specification phase and promised some features that were not delivered. I wanted the store to include upgrades to the car that would carry over to the game feature. This would be anything like car handling, reload times, or adding seconds to the time slow ability. Although I didn't get those completed, I feel like I have the knowledge necessary and the framework in place to implement these features easily in the coming weeks. I think all the features could be a bit more fleshed out for an actual official release of Roadster Run on the Google Play Store, but I am happy with the end result and the current framework to keep building on top of. I did unit testing where I would test features and systems on my PC while developing. Then I did performance testing on my device and devices of my friends. I took all this feedback and optimized and edited the project using Unity's profiling. I do believe I overscoped in the beginning, setting myself the task of the art, the game design, the sound design, designing the Aor functions, designing the store without any plugins or external help. While creating all the art, it was a bit much. I think in the future I'll be looking to the Unity asset store for stuff like particle systems and helpful features like screenshot handling. Although I am very happy with all the features and how they've come out, and that I've managed to have them all functioning. Thank you very much for watching my presentation. Roadster Run is something I'll be working on throughout the summer and hopefully be releasing in August.